Okay, so section 6.5 is on determinants, and we're going to learn how to find them and then one application of them. So a determinant is a number associated with a square matrix. I know that's not like a really special definition, it's not even that descriptive, but that is the definition of a determinant. We actually already found the determinant of a 2 by 2 when we did the inverse. It's that little denominator piece, the third. So to find the determinant of a 2 by 2, you just multiply the diagonals and subtract them. I think I just did my hand backwards. Multiply these and subtract those numbers. So you see an example there of how to do that. All right, anything bigger than that, we're going to use the calculator. But just to show you that you can do things that are bigger, if I have, like, say, I think I'm going to do 1 through 3 by hand to show you in a minute. But, so like if this was my matrix, I would take these first 2 columns and write them out here so that I could finish out my diagonals going in every direction. And then it's just multiply all of these and add, multiply all of these and add, and then subtract what you get. Alright, so doing a 2 by 2, super simple. Multiply 2 times negative 3 minus 1 times 5, and I'm second guessing myself, so I'm going to go back and look and make sure that I'm right. The 4 diagonal minus, that makes sense in my head, I promise. So that diagonal, yes, I'm right, okay. So this diagonal minus that diagonal, sorry. So negative 6 minus 5 gives me negative 11 as that determinant. Alright, so to do the determinant of the 3 by 3, we're going to put a 2, 4, negative 5, and then a negative 3, 2, 3. And we're going to multiply this diagonal. So 2 times 2 times negative 2 plus this diagonal. So negative 3 times negative 1 times negative 5 plus this diagonal. So 1 times 4 times 3. And then we're going to subtract the other diagonal. So we'll go back this time. So we'll do negative 5 times 3. That's not a 3. Sorry. Negative 5 times 2 times 1. Plus 3 times negative 1 times 2. Plus negative 2 times 4 times negative 3. So that top number is, what is this? 4, 8, negative 8. And then negative 15. My memory is horrible today. Plus 12. So up top we get negative 11. And multiplying and adding these, we get negative 10, negative 6, and positive 24. So that would be 8. And then negative 11 minus 8 would give us negative 19. Alright, if I wanted to find the determinant of a 3 by 3 or anything bigger than that, that is, you can find all determinants with your calculator. You can only find the determinant of a square matrix, just like you can only find the inverse of a square matrix. 2 by 2s are easy by hand. 3 by 3s aren't hard, they're just tedious. You get bigger, they just get longer and grosser. So doing them with a calculator will save us a lot of time. Alright, so we will go to matrix and over to edit, choose our matrix. It's a 3 by 3. Put in our value, so 2, negative 3, 1, 4, 2, negative 1, negative 5, 3, and negative 2. Alright, so again, double check your numbers, make sure that they're all right. Then get out of there, second click, and then we're going to find the determinant. So if you go back to matrix, this middle thing, math, the first option there is to find the determinant, DET. So if we choose that and then go back to matrix and say we want the determinant of A, then it will give us that number, and you don't have to do all of the work. Okay, so how can we use the determinant? Well, you can use determinants to solve systems by using what's called Cramer's rule, but it has a lot more steps than a matrix equation. So I don't really see the point in having multiple ways of solving a system using matrices. So you can either solve them the way you've already learned, or you can solve them using matrix equations like we learned in the previous lesson. So the thing we are going to learn about how determinants are cool and helpful is that if I give you the vertices of a triangle, you can figure out the area of that triangle using this formula that you see on your screen, where we can say area is half of the determinant of a matrix we make up out of the vertices, and then we need a column of ones because you can only get a determinant if it's squared, and you're just multiplying by 1 if you put those ones there, so you're not affecting anything. And then this plus minus, why is that there? Well, sometimes determinants are negative, like that last problem that we did, but the area of the triangle is not going to be negative. So if it's a negative, then you multiply by a negative 1/2, so you get a positive area. If you get a positive determinant, you multiply by a positive 1/2, so you get a positive area. All right, so let's try an example. Find the area of this triangle. We're going to do 1/2 times the determinant, and if you do straight bars instead of brackets, that means determinant. So we're going to say 5, 2, 7, 1, negative 2, 3. I just stacked my vertices and then add a column of ones. We're going to figure out what that determinant is, and then we'll decide whether we need to multiply by a positive or a negative 1/2. All right, so if we put this in our calculator, so go to matrix, over to edit, it's a 3 by 3, we have 5, 2, 1, 7, 1, 1, negative 2, 3, 1. Alright, that is alright, I feel like I messed my numbers up. Oh, okay. Alright, so then we want to find the determinant of that, and we get negative 5. Alright, so the determinant using those vertices is negative 5. Remember that area has to be positive, so we're going to multiply by negative 1/2. That's where this plus minus, that plus minus comes into play. So half of 5 is 2.5, and you're finding area, so you should tell me that it's square units. All right, I believe that's all we have for today. All right, so 3 through 7, those are finding the determinant of a 2 by 2. So do those by hand. If you have questions, please let me know.